Hello everyone, my name is Jackson. I'm a software engineer at AI Camp, and today I'll be showing you how you can turn your very own code into a professionally deployed website just like this. First things first, what is this? Well, it's a website using some artificial intelligence to detect emotions in pictures, like so. As you can see, it detects happy. Before we get started deploying code, let's look at some of the things we will need to know and keep in mind before we get everything up and running. First things first, I will reference Docker a lot in this tutorial. If you have no experience with Docker, you might want to read up on it a little bit and install Docker on your personal machine. Docker is something we use to solve issues involving running code on tons of different machines. When using Docker, you don't really have to worry about different versions of requirements. Let's say if you're running an app on Windows and you want to run it on Linux, you want to run it on Mac OS. What you can do is create a Docker container, which is a standard image that everyone can run on their own machine regardless of the host operating system. Docker is better than a virtual machine because it is more lightweight, and you can run tons of isolated apps in their own special Dockerized containers and have them collaborate. Whereas if you wanted to run a bunch of different apps, let's say you wanted to run a bunch of apps on Windows and a bunch of apps on Mac OS and a bunch of apps on Linux, you'd have to run separate operating systems, full-fledged operating systems for each of those if you wanted to use virtual machines. And that would use a lot of memory, would use a lot of CPU usage, whereas Docker, it's a lot faster and a lot more lightweight. Another thing I will be utilizing heavily in this tutorial is the command line interface. If you have no experience with the command line interface, I would highly recommend checking out this tutorial on W3 Schools that covers the command line interface. The command line interface is something you will use a whole lot when developing, and without it you are basically fumbling in the dark trying to debug and fix problems on the fly. So this website will be linked in the description. It is super useful, and it will probably be something you use for the rest of your life, honestly. So I would highly recommend checking it out. Some of the commands we'll be using are these basic commands right here. So ls to show files in a directory, cd to change directory to go places, creating and removing directories, and then there's also commands like sudo to assume super user permissions, basically just running a command as an administrator if the permissions don't permit you to do it normally. apt-get, basically just to install things. It's kind of just like installing stuff on the App Store, but in the command line. It's great. And aside from that, there's some Docker commands which I'll cover later, but all of those are in the command line. And you can't do most of this without command line knowledge, so I would highly recommend checking this out. Next thing I'll be covering is how you Dockerize your project. So if you're doing it from scratch, it will probably be very complicated, especially if you haven't done it before. There's a lot of things to consider and a lot of things you'll run into. However, we can provide this very easy to use public GitHub template where you can just drop your code in, and in theory, it should work. So this template is geared towards Flask apps. This is what this runs on. It's just a Flask app. Flask is super simple, easy to use. Most of your code will probably be in this one file right here, where you basically define all your logic and then all the routes, so like the pages your user can go to. And so this scaffold has a couple of things that make it actually work. First and most importantly is the Docker file. You don't have to understand everything in it, but the main point of this is basically just a layout describing how the actual container, the Docker container, will be constructed. Just installing some dependencies, copying some configurations, installing the pip dependencies, and then just moving some stuff over to the right place for it to actually work. Next thing is the Nginx proxy. Nginx is a web server, and the way it is used in this case is to accept traffic that comes in the Docker file through this port right here, port 80, and proxies it to the actual listener that the Flask app is listening on. It's listening through Gunicorn, which is a pip library, and Nginx just proxies the traffic that comes in to the Docker container to the Flask app so users can actually use your code. And then the final thing that makes this work is the entry point. The entry point just basically starts some stuff up so that the Flask app is all connected and ready to go. Most of this you probably will not have to touch. The only thing you will probably have to touch is stuff in here. Most importantly, the main.py and the requirements.txt. And so with this, there's some common problems and errors that you might run into. The most common one is not having all of your requirements in the requirements file. As you can see right now, there are only two things, Flask and Gunicorn, which actually work, which is actually all this app needs right now. But as you install your own code, drop in your own code, install your own requirements, you'll need to make sure that this requirements.txt file reflects all the requirements you have so that the app can actually run. And then the other common issues are just incorrect file structure and incorrect file names. There's a brief overview of the file structure down here, what you shouldn't and should probably touch. And that is about it for this project scaffold. It most likely should work under all conditions with pretty much any Flask code you put into it. Alright, now I'll be covering the professional hosting option. So this is the option you want to take if you want your project to be up and accessible to everyone on the internet for long periods of time. And so I have a specific technology stack, like a set of applications and websites and services that I will use. Your services may vary, and in that case, the instructions and steps may vary slightly, but the overall process should be very similar. So first things first, if you're hosting a service on the cloud, you need an actual cloud server to host it on. In this case, I'm using AWS EC2. AWS EC2 provides tons of flexible and multi-purpose servers that you can use for pretty much any application. So when you go to AWS, you can go to the EC2 tab, and then you'll want to launch an instance. And now you'll be presented with all sorts of these Amazon machine images. You don't have to worry about the details. You can just choose this Ubuntu Server 2004 LTS. It's probably the most common and most easy to use, so you select that. And then next, you'll want to choose an instance type. Now, this can depend on the complexity and size of the application you're trying to run. Like if it's a super complex web application that loads a bunch of different models and a bunch of code, you might want a slightly bigger instance. But in most cases, you will be a T3 small or a T3 medium will be sufficient for this. And so a T3 small has 2 gigs of RAM, T3 medium has 4 gigs of RAM. Both of them have 2 threads, 1 core, and it will be plenty for hosting a web server. You don't have to worry unless there's dozens of users trying to use it at the same time. So for the purposes of this tutorial, I'll be using a T3 small. So next, details. You don't really have to touch any of this, you can just ignore it. The next is storage. I would recommend for most cases doing something like 50 gigabytes of GP3 storage. This is the cheapest and most efficient option. Would recommend using this option. Anything like 50 to 100 gigabytes will be plenty. You probably won't have to expand it or touch it ever again. Next, tags. Can mostly ignore this. If you want to set a name, you can just type in name. So like this is the name you'll see when you go to the EC2 tab. You can say my project. Next is security group. Now this gets a little complicated. You might need to have some basic understanding of how IPs and firewalls work, but for the purposes of this, it should be pretty simple. You can just leave this default rule here, and also add another one, and then scroll down to HTTP, and then just leave it like that. And add another one, scroll down to HTTPS, and just leave it like that. And then maybe name it something like my project security group. And then you're good to launch it. So note that this will not be free. It will be pretty cheap, something like I think $20 a month for this configuration. Later in this tutorial I'll cover a self-hosting route which would be entirely free, but this route is a lot more reliable. However, there is a small cost associated with it. And then you just click launch. And it will ask you to create or select a key pair. This is for actually connecting to the machine. You will use this later. So in most cases, you'll be creating a new one. You can just name it whatever, my project key, and then make sure you click download, and then make sure you do not lose this, because if you lose this, you will not be able to connect to your instance, and you will have to destroy and recreate it with another key. And once you create it and download it, you can launch it. And it's now being created. So if you go back to the EC2 tab, should be able to see it. We sort by name. You can see my project right here. It's initializing. So in most instances will take a couple of minutes to actually fully start up after you create them. And once that's done, you can actually connect to it and start configuring it. Now that your shiny new cloud server is up and running, next up is to actually connect to it and start configuring stuff. So with that SSH key you downloaded and some details, as you can see right here, I've selected it, and I can see you want the public IPv4 address. I can just go ahead and copy that. What you want to type in your command line is SSH -i. -i specifies an identity file. So in this case it's the myprojectkey.pem we just downloaded, myprojectkey.pem. And then if you selected Ubuntu 2004 as your operating system, the default username will be Ubuntu, and then you do @ and then the IP. So then it will prompt you to trust this fingerprint. Just type yes, and it will probably, it might whine about the permissions on your key file. So in that case, what you'll do is chmod, change mode, basically changing the permissions on the file. Usually something like 600 works. My project key. Now in this case, 600 specifies that only the actual owner of the file can access it. So if we run the SSH command again, it works, and we're in. So as you can see, there's a new little prompt. This indicates that we've connected to the new machine. And then from here, it's all about setup. So one of the things you will need if you want to host this professionally is a domain. Now domain, it's just the thing you see up here, and unfortunately it's something you will have to pay for. Now depending on the name, it could be very cheap or very expensive. For most names that you can think of, you can probably find something very close to it that's cheap. Most domains go for around $14 a year, which I think is very affordable considering what you can get out of it. And the reason you actually need this is to enable SSL or HTTPS. That's basically indicated by this little lock up here that indicates that your connection is secure. Now, if you're just doing this as like a proof of concept or test, you don't really need a domain, but it's still recommended because it improves the security of your app and improves the security for anyone that uses your app. And so a couple of common places where you can buy domains is, of course, Google Domains, and then there's another place called GoDaddy. They both sell domains. They're both trusted sources to buy them from, and they sell most of them at very good prices. So in my case, we will be using the domain ai-camp.dev to launch this test project. And in my case, it's a little more complicated than just managing it all in one place. Usually if you buy the domain, you can set up all the related stuff in the place where you buy the domain, but we wanted some more complex features and controls, so we actually have our domain DNS servers, which is like all the records, let's say, for this site, like let's say app.ai-camp.dev. This part right here indicates a specific IP to go to. Like let's see, right here. As you can see, we have a record for app that points to this IP. So basically, when you type in this URL, it points to a specific IP. And so having a domain is helpful because you can do all of that, and you can also enable secure connections for all the people that use your app. Now here's the fun part, actually deploying the project. So first things first, you'll need to install some system level pre-requirements. It's fairly easy on Ubuntu. You'll just want to type sudo apt-get install, and then we're going to use Docker, which is actually called docker.io, and then to actually set up the HTTPS, the fancy little lock, we're going to use Python 3 certbot nginx. Certbot is a tool that we use to generate the certificates that encrypts the connection, and I just want to use it with nginx, which is the web server, so also installing nginx. And -y. So of course sometimes you'll need to sudo apt-get update, which updates all the lists of packages you can download. So see how they weren't found before? Just give it a second. If we run it again, now they're all found. So that can sometimes happen. It can definitely be confusing. So now we'll go through and install all the packages and all their dependencies under them. And then once all of those are installed, it's a fairly quick process to actually go and get the project up and running. Alright, now that all the dependencies are installed, we can get right back to actually setting it up. So I'll be deploying this template. It's actually good to go as it is out of the box. So you can just copy the URL and run git clone. Then if you run ls, you can see that the Omni code is right there. So if we do cd omni and list the directory, we can see all the files that we have right here. And then, as you can see, we can just follow this quick start guide for local deployment. So we'll run docker. Well, we'll need to run sudo because Docker requires super user permissions. Docker build -t omni dot. And then it will get off to the races, downloading all the required stuff, setting up all the required files, and then running all the installs. And once it's done, if it successfully ran, you should see something like this. Now, in most cases, if it did not successfully run, there should be a stack trace of what exactly went wrong, and usually it's either missing requirements, malformed requirements, or bad file paths. And in that case, you'll need to do a little debugging and fixing that up yourself. And so once that image is built, if we do sudo docker images, you can see right now we have this Omni image, and it's 572 megabytes. So then to actually run the image, we can just copy this command right here, put sudo in front of it, and there it goes. And you may wonder, well, what's happening? Well, a great command to use is sudo docker ps -a. Basically lists all of the running and stopped containers on your system. So you can see this image with named Omni is now running in a container, and it's been up for 9 seconds. If we check it again, it's still up. That means it's probably working. But now what we can do is actually see what's going on inside. We can do sudo docker logs -f. -f stands for follow, basically, and then Omni. And you can see nginx started up, it started Gunicorn, and it is now listening. That means it started up properly. No console barf, no nothing. We're good to go. And so you may wonder, well, how do I actually access this project from my local machine? So if you go back to where your IP is and then copy it and then paste it, you can see it. You can see that it actually shows something. Now this isn't what's actually inside the Docker container. This is just the default page that shows up when you install nginx on the host system right here. So to change that and actually get it showing our project, what you'll need to do is in this Omni directory, there is a host configuration right here. If you look inside the host configuration with a tool such as Nano, Nano is basically just a command line text editor. Super useful to install and learn, not super complicated. You can see that there's all this code right here. Now the only things you'll need to be aware of are these three lines: server name, SSL certificate, and SSL certificate key. These two lines right here basically enable the security SSL, like the little lock right here, and then this server name right here just specifies like the actual name of the server. So that'll be the domain you buy here. So in this case, it'll be ai-camp.dev, but it will have some prefix in front of it normally. If you're not running anything else on your domain, you can just use like ai-camp.dev in this case. But if, let's say, you wanted to run like a web server and then like an email server and then like a couple other projects, you'd have a couple subdomains. And so in this case, it'll be the subdomain. I'm just making this up right now. It'll be myproject.ai-camp.dev, and then you'll want to copy that and then paste it here. Note that these two certificates don't actually exist yet. You'll have to generate them before you actually try and use this configuration, or else it will create some issues. So I'm doing Control O to write it, hitting Enter to just write it, and then Control X to exit. So now what we want to do is actually set up the DNS record so that myproject.ai-camp.dev points to this machine. So once again, we go and copy the IP, and then we head over to whatever panel you use for managing DNS. It could be on Google Domains, could be on Cloudflare, could be anywhere. And what you want to do is you want to add a record. This process should be very similar for pretty much any domain hosting, and you'll want it to be an A record, the name being my project, and then pointing to here. So in this case, myproject.ai-camp.dev will point to this IP. If your provider offers like some sort of proxying or some sort of protection, you should probably turn that off, because in most cases it will interfere with more complicated projects. So then you'll click Save, and now sometimes this will take a second to actually apply and for it to propagate, basically spread all over the world. So you might have to be patient for a little bit. But if we go into this machine and then ping my project.ai-camp.org, you can see it hasn't resolved yet. So just have to wait a little bit. So next thing we'll want to do is actually generate the SSL certificate that we referenced in this host configuration. And so the way you do that is with certbot. It's super easy. It's way easier than other methods of dealing with certificates. It's just like one command you run and you're good to go. The command is sudo certbot nginx. This specifies using the nginx plugin. We'll specify cert only nginx, and then -d stands for domain, and in this case the domain is myproject.ai-camp.dev. And then so this is an email address where it will remind you if your certificate is about to expire. Normally certificates will automatically renew, but in the case that it doesn't, you will need to do some work to renew it yourself. So I'll just put in my email, jackson@ai-camp.org. Then you'll need to agree. You can say no here, and then it just does a little bit of work, and you're good to go. Now if it doesn't work, usually that means you either typed in the domain wrong or put in the domain incorrectly here, like pointed to the wrong IP. It could also just take a second for this to actually reflect and then certbot to pick it up. So you can just be patient. So now you can see that there are new files right here, and those files are already being referenced by the host configuration that we edited earlier. So now we're good to go. So now what we do is we take this host configuration, and we move it to the directory where Nginx actually will recognize it and use it. So that directory is etc. Nginx sites enabled. You can see that there's this one site default, and it's blue because it's a symbolic link, basically just a shortcut like in Windows or Mac OS. So what you can do, you can sudo, because most things in this etc. directory are protected permission-wise, mv move host config etc. Nginx sites enabled, and then we'll just have overwrite default. So now if we list, you can see that it's changed, and if we do sudo service Nginx restart to basically restart Nginx and apply the changes we just made to the website, looks like it's all good. And then we can do status. You can see it's all green, all good. And if we reload this page, or actually if we go to my project a-camp.dev, there we go. Not only do we have a proper certificate, we have a nice domain name, and there you go, we have the index works. That's just what I put in the actual index file. That's just what I put there because it was a placeholder, and that's how it's done. And so at this point you should basically be good to go. From here, what you can do is, if you want to update your code, what you'd normally do is update your code, git push it to GitHub, and then git pull it on your remote server, and then docker build once more, and then docker, you'll want to you'll have to stop or destroy this container and then spin up a new one with this command. That's how you'll basically update it. And that's about it for the professional hosting route. Next up, I will cover how to deploy a project on your own machine. Now, this is the free, less reliable method, and a couple things to note before actually doing this. This is probably not something you want to do long term, especially if you want to expose it to the whole internet. This is probably something you want to do if you just wanted to show it off to friends and family. And so how you go about doing it, the process is mostly the same. You can just, I'm on my local machine right now, just git clone. Then you can go into, go into the directory. You can see all the files right here. And next, it's just the exact same steps as with the professional. You just do, you might need to use sudo, but if you're on Windows, it'll just be docker build. And now this may take a little bit depending on your OS and how fast your laptop or desktop is. But once it's done, like that, once again you'll just docker run, and there you go. And then from there, in most cases, what you'll do is you'll type localhost 9000 in your web browser, and that will open up your web app, just like that. And so some of the differences between this and the actual project, this project can be accessed from anywhere in the world, whereas on the local, it cannot be. There are some steps you can do to make it so that this local can be accessed anywhere in the world, but it's usually not a very good idea and requires a bunch of specific configuration depending on who made your router, whether your desktop is or laptop is a Mac or Windows or Linux. It's very complicated, so that's why I would recommend you guys just use a professional hosting provider like Amazon Web Services, even though it will cost you a little bit. And then you may be wondering, why can't you enable HTTPS or SSL on local? Well, that's because to enable HTTPS, you need a fully qualified domain name, which is complicated mumbo jumbo, basically just saying you need something like this. And you can't get something like that without a hosting provider like Google Domains or GoDaddy. And you can't really you can't have a fully qualified domain name that points to an internal IP address. Like this IP address, localhost, is an internal IP address that basically just tells your web browser, go point towards my machine on this port. And that's the port Docker is actually listening on. It's port 9000, and then it's forwarding it to the actual Flask code right here. So that's pretty much everything. I think I've covered everything from start to finish of how you would actually take your code, put it into a scaffold, and then deploy it on the World Wide Web. Now, of course, some instructions may vary based on a couple of different things in your code, or if you're trying to run it on local, what OS you're using, Windows, Mac OS, they're all different, and they all have their different shortcomings and errors that you may run into, so some intuition and debugging will most likely be necessary regardless of what you do. However, this tutorial was designed to make it as easy as possible to get from point A to point B, and then cover some of the conceptual topics you'll need to have in mind to do this on your own. If you have any questions, feel free to leave them in the comments, and thank you for watching.